Hello everyone. In this video we will be talking about using Venn diagrams to solve problems. This is from section 2.4 in Math in Our World, and this is the last section that we will do in chapter 2. Okay, these are all going to be word problems, so if you want to maybe just jot down the numbers and some of the labels for the sets as you go through, then you don't need to worry about writing down the whole problem. Alright, so here's an example of a type of problem that we can use a Venn diagram to solve. This one says, in an average year, Columbus, Ohio has 163 days with some rain, 63 days with some snow, and 24 days with both. Draw a Venn diagram to represent these averages and find how many days have only rain, only snow, and neither. Alright, so these problems will mostly deal with either surveys or data, some types of sets under consideration. Alright, so this one, the first thing that I would do here is to just try to figure out what is the context of the problem, the universal set, and then how many sets are we talking about, and what do they represent. Alright, so you can kind of tell from the Venn diagram, it looks like we're going to have two subsets of the universal set. Alright, so it looks like we're talking about days with different types of precipitation. Alright, so let's say that A represents days with some rain. Alright, and then B could represent days with some snow. Alright, and so then the universal set, we need to choose some sort of a context. Alright, well, it looks like we're talking about days out of an average year. Alright, so let's let the universe be the days in the year. Okay, now another thing to notice from this problem is that when the problem says 163 days had some rain, that's not actually saying that these are days that only had rain. There is a chance that they had snow or some other type of precipitation. So if you don't see something stated directly in the problem, then don't assume that it's something that wasn't stated. All right, so what we want to do here, the goal is now to find these couple things. How many days have only rain, only snow, and neither? Right? And notice this is a how many question. This is actually a cardinality question. So we're being asked about different cardinalities of these sets in this Venn diagram. So what I want to do next is go through and we talked about these 4 different regions. And I want to try to label each of those regions with the cardinalities of each one. Alright, so looking at the numbers that are given, let me see if I have any of those regions right away. And it looks like we do. We know that there are 24 days with both rain and snow. Remember that both is one of those keywords that means intersection. So there are 24 days in the intersection of sets A and B. Okay, so A is rain, B is snow. Alright, I don't know how many days had neither rain nor snow. I'm not there quite yet. Right, but now I can find how many days had just rain or how many days had just snow. Alright, so think about how you would do that. Well, we know that there are 163 days with rain, and if we subtract the 24 that also had snow, that should leave us with the number of days that had only rain. Right, and notice as a quick check, if you add up the numbers in circle A, then you should end up with the total for circle A. Alright, and then similarly to find the days which only had snow, we can take 63 days that had snow, subtract the days that also had rain, to see that there are 39 days which only had snow. Okay, so that's 3 of the 4 regions. Now the 4th one, we need days which have neither of these types of precipitation. Alright, so the universe represents the days in an average year, so we're going to take that to be 365. And that's kind of like your total. That would represent everything in this whole problem, right? So if we subtracted these numbers, I think we'll end up with just this outside fourth region. All right? So we want to do 365 and then subtract whatever 139 plus 24 plus 39 is. Okay, and that would be, this is 202, so when you subtract, you get 163. All right, and there we have it. We have the cardinalities for all four regions. All right, now again, just to double check, if you add these two numbers, you should get 163. If you add 24 and 39, you should get 63. And if you add all four of these numbers, you should get whatever the total cardinality of the universe is, or 365. And now the only thing that we have left to do is to answer these questions. Find how many days have only rain. Well, that's 139. Put this over here. Only snow, that was 39. And then neither, 163. So the work's already been done for those, but to answer those correctly, you just need to be able to identify the correct region of the Venn diagram. Okay, let's look at another example. According to an online survey, we have a large number of people that reported on this survey. This is their thoughts on Coke versus Pepsi. So we have people who only drink Coke, only drink Pepsi, and then a number of people who drink at least one of those two beverages. So you can see that this one's a little bit different. First of all, we weren't given the number of people who drink Coke. Let's call that A. A is the Coke drinkers, and B is the Pepsi drinkers. Okay, and then the universe. Now for any of these ones which are dealing with a survey, the universe is just going to be the total number of people who were surveyed. Okay, so we don't know, for example, we don't know how many people drink Coke. We only know the number of people who drink only Coke. Same thing for Pepsi. All right, so this one's a little bit different, but what you want to do is start the same way. You have 4 different regions, and see if you can go through and find which one or ones of those you have been given. So it looks like here we know this region and this region, how many drank only Coke and only Pepsi. Okay, so we have 5,786 and 3,763. Okay, so looking at the other two, how can we find these people and these people? All right, that's the question. Well, the ones in the middle would be people who drink both beverages. All right, well, I know that there are 11,405 people who drink at least one beverage. So it could be one beverage or both beverages. So that's giving you the cardinality. If we wanted to say this in set notation, this is the cardinality of A union B, one or the other or both. All right, so if we just subtract these two numbers, the 5,000 number and the 3,000 number, that should give us the people in the middle who drink both. Okay. Okay, and that's 1,856. Now the outside region, people who drink neither, well, we know all 3 of these regions, and we know that the total of all 4 regions is this 12,000 number. So now you just need one more subtraction. Oops. Okay, take the total number of people surveyed, subtract the people in these 3 regions, and then see what's left. Okay, so let me do that quickly. Minus. Actually, is there a shortcut here? I'm thinking we already know, save yourself some work here. We're really just wanting to add these up and then subtract, and we already know the total there. So I think it's even easier than I tried to make this. Okay, so do that subtraction. And I think that leaves you with 1,190 people who don't drink either beverage. Okay, so we have, I think, all of the questions now. Percentage, oh, this is a percentage problem. Okay, so one last thing, remember that a percentage is like a part out of a total, and we just want to convert to, in terms of 100, percents are out of 100. All right, so to find the percentage of people that drink Coke, we just need the total number of Coke drinkers okay, and then if you divide that by the total number of people, that gives you the percentage. All right, I'll let you work that one out. And then same thing for the Pepsi drinkers. Okay, add these two numbers, divide by 12,595, and then same thing for the neither. People who drink neither, divide 1190 by 12,595. Okay. All right, this is a longer problem, and this is going to be our first example of a problem which involves 3 different sets. So watch as we go through. See if you can pick up the clues that let you know that that's the case. A criminal justice major is studying the frequency of certain types of crimes in a nearby county. He studies the arrest records of 300 inmates at the county jail. Okay, so right away that's going to be our universe. Okay, the total number of people that he's surveying. So the cardinality of the universe is 300. He specifically asks about drug-related offenses, domestic violence, and theft of some sort. Okay, so if he's asking about 3 things, those are your 3 sets. So let's let A represent people arrested for drug-related offenses. B is people who were arrested for domestic violence. And C is people who are arrested for theft of some sort. Okay, so as we go through, now we can translate all these different cardinalities and write them in terms of the sets. He finds that 194 had been arrested for theft. Okay, well that's the cardinality of set C, theft. 210 had been arrested for drug offenses. Well, that's the cardinality of set A. And 170 for domestic violence. That's set B. In addition, 142 had arrests for both theft and drugs. All right, so both, that would be, let's see, that's your keyword. That implies an intersection. Okay, so both theft and drugs is both C and A. That's 142. 111 were arrested for both drugs and domestic violence. So that's A, sets A and B. All right, and then 91 for both theft and domestic violence. All right, that's B and C. And 45 for all 3. So all 3, that's actually an intersection again of all 3 sets. Okay, and then we need to answer some questions, but let's make a Venn diagram before we do that. So here I've recopied the relevant information, the cardinalities, and then let me also label these sets too. Okay, so A is drugs, B is domestic violence, okay, and then C was theft. Just want to keep those numbers straight. All right, so let's start out. Now we have 3 different sets, so we have 8 different regions, if you remember how we labeled these before, okay? So what we want to do, we've got 7 inside the circles, and then we have this 8th region outside, which represents possibly any of those inmates who were arrested for something other than those three types of crime. So let's see, I think we can start in the middle again, and a lot of these problems do start in the middle. So this time we know the number of people who were arrested for all three of those crimes, right, 45. All right, and then, all right, so let's work backwards from here. This piece of information, this is people who were arrested for domestic violence and theft. Okay, so B intersected with C. Ignore circle A. If you just look at circles B and C, then their intersection is this region. And we're told that the cardinality of that region is 91. All right, so we've already accounted for 45 people who happen to also have committed drug-related offenses. All right, so if we subtract 91 from 45, all right, that tells you that there are 46 people left who committed only domestic violence and theft crimes. And then subtraction is the way to go for some of these others as well. All right, so 111 people in the intersection of A and B. All right, that's these two regions. All right, so subtract the 45. Okay. All right, and that's 66. And then the intersection of A and C is 142. All right, that's here. Subtract 45. And you get 97. All right, so then how would we find the number of people who were arrested only for drugs? Well, we know that there are 210 people total arrested for drugs. All right, so that represents all of circle A. So we're just going to use subtraction again, and if you subtract the three numbers in the three regions of A that we already have, right, subtract 66, subtract 45, and 97, and that tells you that there are 2 people left who committed only drug-related crimes. Okay, similarly for just B and just C, okay, to find just domestic violence, take 170 and subtract 66, 45, and 46, okay, these 3 numbers, and you get 13 people. And then people who committed only theft-related crimes. Okay, take 194 and subtract 97, 45, and 46. And you should get 6. Okay, and then we have 1/8 region left out here. So same idea, we want to use subtraction again. We know that there are a total of 300 people surveyed, so if you add up and subtract all of the numbers in the union of A, B, and C, right, then whatever's left would go outside here. All right, and you should end up with 25. Okay, so there's the Venn diagram, and now we just need to go back and answer some of those questions. All right, so people who committed only drug-related offenses. All right, that's these people, 2 people. Okay, theft and domestic violence, but not drugs. All right, so that would be theft is set C, and domestic violence, and is an intersection. Okay, but not drugs, so minus the people in A. So C intersected with B minus A. All right, well, looking at your Venn diagram, okay, we have, let's see, C intersected with B is here, and then not A, so we need to not include these 45 people because they also committed drug-related crimes. All right, so C intersected with B minus A is this 46. All right, theft or drugs. All right, remember that or means, that implies a union. So this means C is theft, or is a union, and then A is drugs. So that would be anybody who committed theft or drugs or both. So it's actually the union, all of those numbers in those two circles. All right, so add all of those up. See what you get. Okay, and I think that should be 262. All right, and then none of these offenses, we know that one already. That's the 25. All right, so when you get to these questions, some of them you may already be able to answer. The question is just testing, do you know which region of the diagram to look at? Others, like part C here, we had to do a little bit more work, maybe some addition or subtraction. Okay, here's one more. Let's try this example. You might want to pause and try this on your own, and then I will have the answers displayed, and then you can check and see if you get the hang of this. All right, I've now finished this problem. So I have chosen sets A, B, and C as these up here in the corner. All right, so if yours are different, then just account for that. I also recorded all of these different cardinalities. So we have the total number of people who were surveyed, that's the universe, 500 people. And then we know the number of people listening to each of these three types of music. Okay? And then we also have some information about intersections. So we have 140 people listening to rock and hip hop. Okay, so both and are keywords for an intersection. So we have the cardinality of B intersected with A, rock and hip hop, that's 140. Okay, we have rock and country people, 120 of those. And then hip hop and country, we had 80 listeners for that set. And then finally down at the bottom here, the number of people listening to all three types of music would be 50. Okay, and then on the right, I filled in the Venn diagram, so if you've paused and filled this in on your own, then you may want to check against that. All right, notice that we could start in the middle here, 50 listeners for all three types of music. And then you go back and look at these intersections, 140, 120, and 80. Subtract 50 from each of those, and that's where we get 90, 30, and 70. All right, and then finally, the 100, the 110, and the 10, okay, we get those by subtracting the numbers that are there from the cardinalities of A, B, and C. All right, so for example, this 100, that comes from taking 270, the total number of people in set A, and then subtracting 90, 50, and 30. All right, and then once you've done all of that, all right, if you add up all of the people in these three circles and subtract from 500, so 500 is the total number of listeners. Okay, 500 minus all of those gives you 40 people left who didn't listen to any of those three. All right, so let's look at the questions now. Some of these we should be able to answer from the diagram already, and then others we may need to do more subtraction or addition. Okay, people who listen to only hip hop. All right, that's 100. That's these people. Rock and country, but not hip hop. All right, this would be rock, that's B, and country, B and C, but not hip hop. So we could say minus A to account for that. Right. Okay, so B intersected with C. That's rock and country, but not hip hop. So we don't count the 50 people listening to all three because they were hip hop listeners as well. Right, so this is just 70. Don't listen to any of these three types of music. We know that one already, that's 40. And then finally, don't listen to country music. Two ways you could have done this one. One way is to just add up all of the people who are not in that country circle. This is like C complement. All right, so we could add 100, 90, 110, and 40. All right, and that gives you 340. A second option would be to take the total number of people, 500, and subtract away people who listen to country. Subtract 160. And then you still also get 340. Okay, we will stop there. I have a few more examples to do from this section, but I'd like to make a second video from this section and talk about some of the other types of problems that you could see. We'll still do ones with 3 sets, but with different starting information. So we don't always have this middle number as a place to start. So we'll do a couple trickier ones. All right, that's it then, and thank you for watching.